Okay, picking up where we left off yesterday, analyzing a quadratic function. A frog sitting on a rock jumps into a pond. The height h in centimeters of the frog above the surface of the water as a function of time t in seconds since it jumped can be modeled by the function h of t equals negative 490 t squared plus 150 t plus 25. Where appropriate, answer the following questions to the nearest tenth. Part A. Graph the function and provide a sketch. So, with our graphing calculators, if you're using a Casio, go menu and then number 5. If you've got an equation in there already, you have to delete it. So F2 for delete, F1 for yes. Then I'm going to enter my equation. So negative 490 x button is right below alpha. We use that same button no matter what the variable is. So instead of putting t squared, I'm putting x squared plus 150x plus 25. Hit EXE. It'll drop us down to y2 and you'll see the options on the screen. So F6 is draw. Push that. Now, probably from yesterday, your window is set to like negative 10, positive 10, somewhere in there. If that's the case, I see a very, very skinny parabola, so it looks something like this. And it goes like way off of my chart somewhere, so something like this. If I want to see things a little better, I can tell that I want to go up. And I don't need to see as much of the x-axis as it's showing me because it's a very narrow parabola. So I am going to go to my window, push F3 for window. For my x-min, this is about the height of a frog and the time in seconds. So the x-axis, the independent axis, is always time if time isn't a question. I don't need to know about negatives, really. So I'm going to go like negative 1. And then my max, the frog is not going to be in the air for very many seconds. So I'm going to go like 2. My scale I can leave at 1. Then I need to use my down arrow. If I keep hitting EXE, it'll like bump me out of here for some strange reason. So I need to use my down arrow to go to Y-min. The minimum, or the y value, is related to the height of the frog in jumping. So obviously the frog cannot go below the ground. It has to land on the ground. So I don't really care about the negative. So I'm going to go negative 1 again, just so I can see the axes, but I'm not really looking at negative numbers. My max, right now my max for my calculator happens to be at about 18. And I definitely want to go higher than that. If I remember from yesterday, my y-intercept, when I'm in standard form like this, we have ax squared plus bx plus c. My y-intercept is the c value. So my y-intercept is 25, which means my max should be even higher than that. So I'm just going to put in something that's for sure higher than 25. So I'm going to go 50. Hit EXE, and then hit EXE again. Takes me back to my equation, and then hit F6 for draw. Okay, so now I'm just gonna change my picture here. I have something that looks like this. Okay, so my parabola looks something like that. This is the time. This is the height. We had our y-intercept was at 25. Let's use the calculator to find our vertex. So F5. It's a max, so F2. And it is at 0.15 and the y value of 36.4. So that's our vertex. Let's find our x-intercepts. G solve root. My first one is negative 0.12. My second one, if I just use the right arrow, is 0.43. Part B, what is the y-intercept and what does it represent in this situation? So we said that the y-intercept was 25. What does it represent in this situation? Well, at the y-intercept, the time is 0. So this is the height of the frog at time 0. Remember, the frog is sitting on a rock, right? A frog sitting on a rock jumps into a pond. So the height of the frog at the initial time when it's sitting on the rock is 25, what units is it? 25 centimeters, okay? So 25, and it is the initial height of the frog while on the rock. Part C, what maximum height does the frog reach and when does it reach that height? So the frog reaches a max height of, that would be our y value of our vertex, 36.48 centimeters at time 0.15 seconds. That's the x value of our vertex. Part D, when does the frog hit the surface of the water? At the surface of the water, the height would equal 0, which means this is an x-intercept. So our x-intercepts are negative 0.12 and 0.43. The negative one does not matter here because remember, we can't have negative time, right? So we started here. The graph is only relevant from this point on. So the only x-intercept that matters is the 0.43. So the frog hits the water at 0.43 seconds. Part E, what are the domain and range in this situation? Our domain in this case is about time, t, and t definitely has to be greater than or equal to 0, but also in this case it's going to stop when we get to this x-intercept 0.43, because if we keep going, the graph goes below into negative heights, and that's not going to be possible. The frog is not jumping through the ground. So it's going to go from 0. 0 is less than or equal to t, which is less than or equal to the x-intercept of 0.43, comma, t, e, r. And the range is the height. The height is between the max value and 0. So it's bigger than or equal to 0, but less than or equal to our max height. So h, such that 0 is less than or equal to h, which is less than or equal to 36.48, comma, h, e, r. Part F, how high is the frog 0.25 seconds after it jumps? So 0.25 seconds, that's a t value. We can plug that in to our function. H of 0.25 is what we want to know. So that means plug in 0.25 for t everywhere that there is a t in the equation. So our equation is negative 490 t squared. So negative 490 times 0.25 squared plus 150t. So plus 150 times 0.25 and then plus 25. Then we're going to calculate that. So menu 1 to get back to our calculating screen. Negative 490 times 0.25 squared plus 150 times 0.25 plus 25. That gives me h of 0.25 equals 31.88 centimeters. So the frog is 31.88 centimeters above the water. .25 seconds after it jumps. Okay, I'm just realizing that it says to round to the nearest tenth, and I rounded all my values to the hundredths place. So you guys can round them to the tenth, or we'll just pretend that it said round to the hundredths place. Also, you might wonder why our range is restricted to being greater than or equal to 0, when if you think about the question, the frog is jumping to the surface of the water, and technically the frog could go below the water, but air and water are different. So the frog traveling through the air is represented by this formula. But when the frog hits the water, if it was just to stop moving and sink into the water, that parabola or that graph that it would look like, it wouldn't be on the same trajectory as this, right? So it would be slowing down because of the resistance from the water. So it might like come down like this and then maybe start going like this kind of thing, something like that. So that's why we restrict our range to just being related to the frog in the air. This function that we're given is only about the frog jumping in the air. It does not represent the frog sinking in the water. Writing a quadratic function to model a situation. A rancher has 100 meters of fencing available to build a rectangular corral. Part A, write a quadratic function in standard form to represent the area of the corral. So they have 100 meters of fencing available to build a rectangular corral. That would be the amount they're going to use around the corral, which would be the perimeter. Perimeter, because it's rectangular, is 2 times the length plus 2 times the width. The P would be 100. 100 equals 2 length plus 2 width. I'm going to isolate one of my variables, doesn't matter which one. So I'm just going to subtract 2L here, minus 2L on both sides. That gives me 100 minus 2L equals 2W. Then I'm going to divide by 2 on all the terms to get the W by itself. And I have W equals 50 minus L. We want to write a quadratic function in standard form that represents the area of the corral. Again, it's a rectangle, so area would be length times width, which is length times, we just decided or determined that the width is equivalent to 50 minus L. I can't have three variables, so I can't have A for area, L for length, and W for width in one quadratic function. I need to just have area and either length or width. So that's why I isolated for W. Now I can write length times width as length times 50 minus L, because 50 minus L is the same as the width for this question. Then if I multiply that L into the brackets, I have area equals 50L minus L squared. If I want to put it in standard form, then it would be area equals negative L squared plus 50L. And there is my quadratic function representing the area of the rectangular corral. Part B, what are the coordinates of the vertex and what does the vertex represent in this situation? Let's do this one algebraically. We'll do it algebraically and graphically. So remember from yesterday, to algebraically find the x value of the vertex, x value, we use the formula x equals negative b over 2a. So in this case, b is 50. So negative 50. A is negative 1 because it's a negative L squared. So negative 1 in front of L squared. So 2 times negative 1 on the bottom, which is negative 50 divided by negative 2, which is 25. So our x value of our vertex is 25. Really, this is the L value. So L value and L equals. Then to get the y value of the vertex, which in this case represents the area, so the A value, we substitute in the value we got for our length, or the x value of the vertex, into our quadratic function. So we have negative 25 squared plus 50 times 25. Then we calculate that. Negative 25 squared plus 50 times 25 gives me 625. So my area is 625. Then putting them together, our vertex is 25, 625. The x value represents L, the length. The y value represents A, the area. So the max area is 625 meters squared, which occurs when the length is 25 meters. Oftentimes these questions will ask for the dimensions of the rectangle, so it wants both length and width. It didn't ask that here, but let's find that anyways. We have from part A this formula. Width equals 50 minus length, and we know that our length at the max area is 25, so we plug that in. Width equals 50 minus 25, so the width in this case also equals 25 meters. Part C, sketch the graph for the function you determined in part A. So we'll go to our graphing calculator. We already know our vertex, but we'll go to our graphing calculator and plug in this equation. So negative x squared plus 50x is what I'm typing into y1. So I got there by doing menu, number 5, And then I deleted what was in my y1 from the last question, typed in negative x squared plus 50x, hit exe, then F6 for draw. My window is really funky, so it kind of looks like a straight line right now. It is not a straight line. I want to fix my window. So I'm going to go F3 for window. If I think about this scenario, okay, I already know my vertex. My vertex is the length is 25 and the area is 625. So the x value, again, I don't care about negatives because it can't have a negative length. That doesn't make sense. So I'm going to keep that -1 for my x min. My x max has to go to, well, 25 is where the vertex is. So I'm going to make it like 50 because 25 from 0 to 25 and then 25 more for symmetry would get me to 50. So I'm going to go 50. Hit exe. Scale, I can leave it 1. Go pass, go down, down, go to y min. My y values are talking about area. Again, can't have negative area, so leave that at -1. My max, I know my max is 625, so I'm going to go up to 650. Hit exe, exe, F6 for draw. And my parabola or my image on my screen looks something like this. The x-axis is the length. The y-axis is the area. We know our vertex is at 25 and 625. Let's confirm that with the calculator to make sure we did it right. So F5 and F2 for max. And yes, 25, 625. Let's find the x-intercepts. The first one should be at 0, 0 because when the length is 0, the area is going to be 0. But let's confirm. F5 root 0, 0. And next one, use my right arrow, and it is at 50. Makes sense because we know that we have a line of symmetry that goes through the vertex. So if this goes from 0 to 25, then there's got to be 25 from the midpoint to the next x-intercept. So that would take us to 50. Part D, determine the domain and range for this situation. So our domain is going to be between the two x-intercepts. So domain is the length such that 0 is less than or equal to L, which is less than or equal to 50, LER. Or in interval notation, it would be square bracket because includes 0, comma, 50, square bracket again because it includes 50. Our range would be about the area, so A such that area has to be between 0 and our max of 625. So 0 is less than or equal to A is less than or equal to 625, comma, AER. Or if we were writing it in interval notation, again, we'd have square brackets because 0 is included, then comma, 625, and square brackets because 625 is included. Part E, identify any assumptions you made in modeling this situation mathematically. Well, for one, we are assuming that there are no other restrictions on the size of the rectangle. So maybe the place that he was going to put it is not going to hold as big of a rectangle as we calculated. We're assuming that there are no restrictions like that, okay? Another thing that we are assuming is that he is going to use all of the fencing. Okay, so the farmer's going to use all of the fencing because we said that our perimeter is going to be 100. He's got 100 meters of fencing. There could be other assumptions, but those are really the two that I can think of. So you should now be able to finish those practice problems for this section, and tomorrow we'll be moving on to the next lesson.